Using our velocity time graph for constant acceleration, we have already derived two equations. Equation 1 was final velocity equals initial velocity plus acceleration times the time interval. And equation 2 was the displacement equals 1/2 times the initial velocity plus the final velocity times the time interval. So we are now going to come up with two more equations. Right here we're going to come up with an equation that does not have a v final in it. And then over here we're going to come up with an equation that does not have a delta t. So to do that over here, we are going to substitute equation 1 into equation 2 to eliminate the v final variable. So here we go. This is getting substituted here. So that gives me displacement equals 1/2 times vi plus this whole thing, vi plus a delta t times delta t. Now we're going to simplify. I can add together the vi and the vi. That gives me two vi's. And now I'm going to multiply the 1/2 into the inside of my parentheses. So that gives me vi plus 1/2 a delta t. And now I'm going to multiply the delta t throughout. So we get delta t squared. Okay, so displacement equals initial velocity times the time interval plus 1/2 acceleration times the time interval squared. It's the whole delta t thing here that is squared. Okay, so this is our equation 3. Now to find equation 4. It says solve equation 1 for delta t, then substitute into equation 2 to eliminate delta t. So let's start with equation 1 and solve it for delta t. So I'm going to subtract vi from both sides. And now I'm going to divide both sides by acceleration. I'm trying to isolate the delta t. Okay, so we have delta t equals this thing. And now we're going to substitute that into the second equation. So substituting, this whole thing is going to go in for delta t. So I have vf minus vi over acceleration. And we need to simplify this. So I'm going to remember that I could view this as a fraction, and I can multiply all my denominators together, and I can multiply the numerators. So on top, I have vi plus vf times vf minus vi over 2a. So now I'm going to multiply out the top. So that gives me vi vf plus vf squared minus vi squared minus vi vf all over 2a. And since I know I'm going to be solving for vf squared in the end, because that's how this equation is traditionally written, I'm going to multiply both sides by 2a so I can get rid of this fraction. So multiplying both sides by 2a gives me 2a delta x equals, these cancel out. Let's see what I have in here. This is a positive VIVF and this is a negative VIVF. So those add together to make 0. And I get VF squared minus VI squared. So now to isolate VF squared, I can add VI squared to both sides, which gives me 2a delta x plus vi equals vi squared equals vf squared. And this equation is usually written just flipped around the other way. So VF squared equals VI squared plus 2A delta X. So if you see it in a book or on the equation sheet, this is what it will look like.